Okay, this is my circular motion reassessment. For this one I did an 84 kilogram person gets on a Ferris wheel at a fair. The Ferris wheel has a radius of 13 meters. It rotates a full revolution every 42 seconds. When the cart the person is riding reaches the top of the wheel, what is the apparent weight of the person? So this is the free body diagram here. This is where the person is in the cart. The normal force is going to be up, and the mg, the mass times gravity, is going to be down in the y direction. Radius from middle of the Ferris wheel to where they are is 13 meters. So to convert into radians per second, we're going to take the one revolution, which takes 42 seconds, and divide it by 2 pi radians to get 0.15 radians per second. Then you take the equation acceleration equals the angular velocity squared times the radius, and F net equals n minus mg, which also equals ma. So we'll take a here and plug it in for the ma down here. So to bring this whole equation together, it's going to be here in the normal force minus the mass times the gravity equals the mass times the angular velocity squared times the radius. So we're going to try to get n by itself so that we can find, the question is, what is the apparent weight of the person, which is n. So we're going to put n by itself. So n equals mg, mass times gravity, minus the mass times the angular velocity squared times r. And the reason this is negative is because the acceleration is down in the y direction towards the center of the Ferris wheel. So now we just take all of our numbers from the equation, and we're going to do the normal force equals the mass, which is 84 kilograms, times the gravity, 9.8, minus the mass, 84, times the angular velocity, which we figured out up here, 0.15 radians per second, squared, times the radius, which was 13 meters. And plug that in the calculator, and you get the apparent weight of the person is 798.63 newtons.